In the pre-lab this week, you will have to predict FTIR of benzoic acid and 9-fluoronon. This example video will hopefully help you understand the pattern of identifying functional groups, looking at structures of molecules, and relating it to FTIR, and hopefully help you better answer the questions on the pre-lab. So for an example molecule, I chose triphenylmethanol, which is, it shows up in Organic Chemistry 2 lab. And when I look at the structure of this molecule, which I drew out here, I can identify two functional groups. The first one that I see is a hydroxyl group, or an alcohol. So we have our hydroxyl, and that is the bond between, a single bond between oxygen and hydrogen. So looking at the chart, which we're given in the pre-lab, definitely utilize this chart. When I look at the chart, I see this bond type, and I see that it's associated with peak wavelength of 3650 to 3200. And what this means is we can expect this stretch, this functional group, to show up between these values. So super important to know. The table also shows us the peak size and shape, so the phenotype of this functional group, if you will. And for our alcohol, it says strong and broad. So obviously this isn't drawn to scale, but this is kind of what we can expect for the hydroxyl group. It's very distinct compared to other functional groups because a lot of functional groups show up with that very harsh peak, whereas this one is more of a scoop. It's very broad. So that's what we can expect between that range for this functional group. The other functional group in this molecule is our benzene, or our aromatic functional group, and there's three of them, hence triphenyl, but I'm just going to label one, so our aromatic. And looking at the table, I can see that stretch is between 2000 to 1650. So that's where we can expect to see the rings show up. And when I look at the size and shape, it says teeth, which I know is an interesting description. And it also says weak. So what we can expect is between 2000 and 1650, this functional group will look something like that. Again, not drawn to scale, so keep that in mind, but that is what we can look for on our own FTIR if we're comparing triphenylmethanol to our product. So this characterization technique is super important in order to determine the success of our separation, synthesis, whatever we're doing in lab, because we can compare the FTIR of our product and the functional groups of our product to that of the starting material or the desired product, whatever we want the outcome to be in lab. So hopefully this helped you, and if you have any questions, be sure to talk to your TAs.